We're going to solve and graph this compound or inequality. In order to do this, we must solve each of these two inequalities individually. Beginning with the inequality on the left, we have 3x plus 8 is greater than or equal to 17. First, we subtract 8 from both sides. Thus, we get rid of that plus 8 on the left and just have 3x. And on the right, 17 minus 8 gives us 9. So 3x is greater than or equal to 9. Now we can just divide both sides by 3 to finish getting x by itself. 3x divided by 3, of course, just gives us x on the left. And on the right, 9 divided by 3 is 3. And so we have that x is greater than or equal to 3. Next, we'll solve this inequality. 2x plus 5 is less than or equal to 7. To solve this, we begin by subtracting 5 from both sides. Thus, that 5 on the left is cancelled out, and on the right, 7 minus 5 gives us 2. So we have 2x is less than or equal to 2, and then we divide both sides by 2 in order to finish solving for x. Then on the left, we just have x, and on the right, 2 divided by 2 is 1. So we have that x is less than or equal to 1. Now we've solved the individual inequalities, and so the compound inequality has x is greater than or equal to 3, or x is less than or equal to 1 as its solution. So that's the solution to the compound inequality, x is greater than or equal to 3, or x is less than or equal to 1. We can get a better idea of exactly what this means by graphing it on a number line. Graphing a compound inequality involves graphing each inequality individually. So first, let's graph x is greater than or equal to 3. So on our number line, we come over to 3 and put a solid dot at 3. That's because equality is allowed here. That's why the dot's solid. Since x has to be greater than or equal to 3, we'll then draw an arrow pointing to the right, to the numbers that are greater than 3. Then we also have to graph the other part, x is less than or equal to 1. Again, equality is allowed here, so at positive 1, we put a solid dot. Then, since x is less than or equal to 1, we draw an arrow going to the left, towards the numbers that are less than 1. So that's how to solve the compound or inequality, and that's how to graph it. Here's an example to try on your own. Solve and graph this compound or inequality. I'll put the solution on screen now. As before, we have to solve each inequality individually, and that gets us these two inequalities. We can attach an or in between them, and that is the solution to the compound inequality. And then graphing them on the number line is similar to before. Notice that for this inequality, x is less than -2, equality isn't allowed, and so we have an empty circle there. So that's how to solve and graph a compound or inequality. Let me know in the comments if you have any questions, and be sure to check out my Algebra 1 course and Algebra 1 exercises playlists in the description for more. Thanks for watching.